is the SCR-545. It's another step in the development of radar equipment for use in anti-aircraft fire. Like the 268, it seeks out enemy bombers long before they can be seen or heard. But in several important ways, it's a lot better than the 268. First, this 545 can track targets automatically. After you've located a plane and tracked it by hand until the signal is steady and strong, all you have to do is throw a switch and the 545 continues to track the plane by itself. The second improvement is its accuracy. It will supply data needed by any director, M4, M7, M9, M10, or T20. It can give out with the altitude, slant range, azimuth, and elevation of a target, depending on what's wanted. And guns that use the 545 data really get hit. That's why it's known as the gun-laying radar. It is a mobile unit and very compact. Here on the road is the whole outfit, a prime mover carrying the power plant and a four-wheel trailer carrying the radio equipment. For tough going over rough terrain, the battery commander will probably use an M4 tractor to do the pulling. But for normal roads, this prime mover can hold its own with the rest of the convoy. Now let's take a look at how the 545 is set up. It does a better job if it's located in an open, level spot like this, free from power lines, metal towers, and buildings. By the way, the second truck that's joined up here carries enough spare parts to supply 4 545 radio sets. The moment the unit comes to a stop, set the handbrake on the trailer, unhook the safety chain, uncouple the brake cable, open the pintle, and hold up the drawbar so the prime mover can pull out. At the same time, take the canvas cover off the antenna. It's a heavy job and will probably need 3 of you on it. And of course, the neater you fold it up, the easier it'll go on when you hear march order. The power cable is 250 feet long. Within that limit, it's a good idea to park the power plant as far away from the 545 as possible for maximum dispersal. That'll make sure one bomb doesn't knock out both units. Now, back to the trailer. Run the front jacks in a bit to unlock them from their traveling position. Then swing them down in place and put the foot plates under the jack spindles to spread the load. The 545 must be perfectly level and remain steady to operate properly. That means you have to jack the whole trailer up off the ground. It weighs 13 tons. That's why each jack needs 2 of these heavy braces. When the braces are in place, the jack spindle can be run down enough to center the foot plates before tightening the lock nuts at the trailer and outrigger end. By this time, the men on top have folded the cover and stowed it away. Right now, they're locking the left side of the antenna reflector in place. You see, the reflector is wider than the trailer, so during travel, both sides are folded up out of the way. Now that they're down and locked, loosen the bolts that held the reflector steady in traveling position. Now lower the other 2 jacks at the back of the trailer and put the foot plates under them. Put the braces on and tighten the lock nuts. Unfasten the chain holding the cover rail and lower it to make room for the traverse of the antenna. Remove the spotter seat from its traveling position and clamp it to the side of the pedestal. Before long, you'll see how the seat is used. Then crank the antenna up into its operating position. It's no lightweight, so it'll take a bit of time to get it up there. Meanwhile, open the doors on both sides of the trailer so you can make the necessary adjustments to get into operation. There's the track transmitter, the track receiver. Here's the brains of the outfit, the automatic controller, and the power behind the 545, the high voltage rectifier. Then couple the transmission line to the track transmitter. The radar repairman is responsible for this job because it's ticklish. Make the inner connection, then fit the two halves of the outer sleeve in place, slide the coupler over them, and tighten it. Replace the 8 dipole ends that were taken off so the sides of the antenna could be folded up. In searching, these dipoles transmit the pulse and receive the echo that bounces back from the target. At the center of the antenna is the track scanner. It gets power over this transmission line that the radar repairman is connecting. The power comes up through that coaxial line there in the middle. It goes into the plastic shield where the rotating scanner, that metal cylinder, sprays the radio waves against the curved surface of the reflector. From there, they bounce out into space. Some of them strike the target and return to bounce back into the scanner, then on down to the track receiver. The scanner turns at 3,600 revolutions per minute, so it must be oiled at least once a day. To tune it, pull this plunger out to its marked setting and lock it. By this time, the antenna has been cranked all the way up. Next, you have to bolt the hinge joint together to make sure the antenna is lined up with the pedestal and held firmly to it. Swing the antenna up out of the way so you can get out the stud bolt. You'll find the wrenches, 4 of them, chained to the pedestal, handy for the job. Now that the pedestal is bolted down, you can connect the antenna transmission line. Again, the coupling is made under the supervision of the radar repairman. This is another link in that line from the track transmitter up to the scanner and back. But it also carries radio power from the search transmitter to the dipoles you saw a while ago and back to the search receiver. Therefore, the connection must be made carefully and securely, and above all, it must be clean. Make sure that the sleeves and connectors are shiny bright, or those bombers will be on top of you before you can pick them up. Now let's jump over to the power plant and see what's going on. The moment the driver stopped, he hopped out to open all the doors on the unit and check the motor. This power plant furnishes single-phase, 120-volt, 60-cycle power, just like you use on the 268. Back to the trailer, where you're ready for leveling. The chief of section gets up where he can see the level bubbles and directs the men at the 4 jacks to raise or lower the trailer until the bubbles are centered. As he looks down the rear hatch, this is what he sees. These small course miles are the ones you'll use for rough leveling. The large ones are for the final accurate leveling. While you're on the road, these big vials are removed and carried in a case in the trailer cab. This blower, by the way, cools the motor that drives the antenna pedestal in azimuth. Notice that in leveling, the men at the jacks always work in pairs. 2 left, 2 right, 2 front, or 2 rear. Thus, they move only 1 bubble at a time and also avoid any twisting strain on the chassis. The power junction box is at the front of the trailer, and here's the power plant operator hooking up the power cable. One lead is shorter than the other, so there's no danger of your grounding the hot side of the line. Then at the other end of the trailer, pound in the special ground stake. This is made of steel with an outer coating of copper. Be sure to drive it well into the ground and fasten the lead securely to the terminal on the chassis. The 545 can furnish data to any type of gun director without making any internal adjustment. All you have to do is hook the cables onto different plugs here at the data junction box and set the switch inside for the director you're using. These two sockets in this setting will be used for the M7 director. Now let's assume that the set has been oriented and synchronized and see what goes on during operation. The three operators take their places in the light-proof cab and close the door so that they can see the oscilloscope screens without using sight tubes. Here's how the cab looks inside. In front of each man is a control unit and two oscilloscopes. The search scope has a longer range, so you use it to pick the plane up when it's way out and follow it in until it appears on the track scope. Then you can use the track scope to obtain accurate gun laying data long before the target is within range of the gun. And here's how the spotter seat is used. One of the other men is detailed as an observer. He rides with the antenna and has a direct phone line to the men in the cab. Through this elbow telescope, he can look out along the center of the path taken by the radio pulses and see the target as it's tracked. Thus, he can help the operators improve their manual tracking as well as check up on the accuracy of the 545 when it's tracking automatically. And of course, this spotting telescope is invaluable in orienting. Now let's go below and take a look at the control units. Each operator has his own hand wheel, so he can operate manually. Here, for instance, the elevation tracker is using manual aid-off tracking. That simply means the selector switch there at the left is set at manual, and the aid switch in the middle is at aid-off. Now the antenna will elevate or depress only when he's turning the hand wheel. Of course, when the azimuth operator uses manual aid-off tracking, the antenna will move in azimuth only while he's turning the hand wheel. Normally, you'll use manual aid-off in azimuth only when lining up on an orienting point. In searching, it's much better to switch over to manual aid-on. Leave the selector switch at manual, but flip the aid switch to aid-on. Then the antenna will traverse at whatever rate you set in with the hand wheel. The moment a plane is picked up, all three operators go to manual aid-on and establish the correct rate of tracking. Just as on the 268, the azimuth and elevation trackers split the echo and match the height of the two halves. But the range operator there at the far side, instead of moving the echo to a hairline to get the range, moves a notch in the baseline to the echo, like this. As soon as the pip is in the notch, the range operator throws the selector switch to automatic. The azimuth and elevation trackers do the same as soon as they have balanced their split echoes. Now the 545 tracks the plane by itself. It does as consistent and accurate a job of tracking as the best trackers in the outfit and relieves you of having to sweat it out trying to follow the target manually. And there it goes, dead on the plane, rain or shine, day or night. Now how do you think a Nazi or Jap pilot feels up there? Knowing you've got him spotted, knowing that no matter how he twists or turns, the finger of radar is always on him, and your guns are just waiting until he gets in range before blasting him to kingdom come. It might occur to him that a fella can't win when he's fighting against a nation with the inventiveness and resources to produce weapons like this.